Welcome to our comprehensive guide on Android system design interview questions and answers. Whether you're preparing for your next big interview or simply looking to deepen your understanding of scalable Android architecture, this video will walk you through the most essential concepts, practical strategies, and real-world examples. We'll cover everything from app architecture patterns to caching, notifications, security, and more. Let's start by setting the stage for what makes Android system design so critical in today's development landscape, especially as apps grow in complexity and user base. Designing an Android app for scalability and maintainability starts with choosing the right architecture. Patterns like MVVM, Model View Model, and MVI Model View Intent are popular because they separate concerns, making the codebase easier to manage and extend. The model holds data and business logic. The view represents UI components, and the view model acts as a bridge, processing data and updating the UI. This separation allows for independent testing and easier feature additions, ensuring your app can grow without becoming unmanageable. Effective caching is crucial for performance and reliability. Android apps typically use three layers: in-memory cache like LRU cache for fast access, disk cache using room or shared preferences for persistent storage, and network-based caching with retrofit and OK HTTP for offline functionality. By combining these layers, you ensure data is accessible quickly and reliably, even when the device is offline. This approach not only improves user experience but also reduces server load and bandwidth usage. Notifications keep users engaged and informed. Android supports push notifications via Firebase Cloud Messaging (FCM) and custom servers. For Android 8 and above, notifications are grouped by channels, allowing users to control preferences. Intent handling lets notifications trigger specific actions, and you can use local notifications for reminders or scheduled events. By distinguishing between remote and local notifications, your app can provide timely updates and maintain user engagement. Synchronizing data between server and app is vital for consistency. The repository pattern acts as a single source of truth, deciding whether to fetch data locally or remotely. Work Manner schedules background tasks, ensuring synchronization even if the app is closed or the device restarts. Using APIs with last modified timestamps or e-tags minimizes data transfer, syncing only what's changed. This approach keeps data up to date without draining battery or using excessive bandwidth. Offline functionality is key for user satisfaction, especially in areas with poor connectivity. Store essential data locally using Room or SQLite, and sync with the server when the device reconnects using Work Manager. Notify users when offline and provide feedback on available data. Optimistic UI updates let users see changes immediately, syncing them in the background. These techniques keep your app responsive and functional, even without network access. Protecting user data is paramount. Encrypt data at rest using encrypted shared preferences and encrypted room and in transit with HTTPS. Implement OAuth 2 for secure authentication and use libraries like Firebase Authentication or Auth0 for access management. Avoid storing sensitive information in shared preferences or files. Use Android's KeyStore for encrypted keys. Obfuscate code with ProGuard or R8 and request only necessary permissions to reduce risks and build user trust. Images can impact performance, so efficient loading and caching are essential. Libraries like Glide and Picasso handle image loading, caching, resizing, and transformation. In-memory caching quickly displays recently used images, while disk caching stores images that don't change often. Show placeholders during loading and error images if loading fails. Resize or downsample images to save memory, ensuring your app loads images efficiently without excessive resource use. Building a chat feature like WhatsApp requires real-time communication and robust architecture. Use MVVM or MVI to separate UI from backend logic. Store messages locally with room for offline access, and sync with a server using Firebase or custom solutions. Push notifications alert users of new messages, and real-time updates are achieved with WebSockets or Firebase real-time database. Encrypt messages to ensure privacy and security. For image sharing features, compress images client-side to improve upload speed and reduce server load. Use Work Manner for background uploads, and store images on cloud services like AWS S3 or Firebase storage for scalability. Cache images locally with Glide or Coil to reduce load times and bandwidth usage. Integrate a CDN for global distribution, and use pagination for large galleries to enhance performance. Offline-first approach prioritizes local storage and periodic syncing with the server. Use Room for local data and Work Manager for background sync. Handle conflicts with timestamp or user preference-based resolution. Monitor network availability with Connectivity Manager, and maintain data versioning to ensure the latest information is always available. This strategy keeps your app functional and responsive regardless of connectivity. Handle millions of users. Use modular architectures like MVVM or MVI for maintainability. Scale backend with cloud services offering load balancing and caching. Optimize networking with retrofit and HTTP caching, and enable gZIP compression. Optimize Room database with indexing, and use image compression and lazy loading for efficient content management. Monitor performance with Firebase Crashlytics and performance monitoring. Commerce apps need diverse notifications, promotional, order updates, and reminders. Use FCM for push notifications and local notifications for time-sensitive updates. Allow users to set preferences for notification types and frequency. Enable deep linking so users can jump directly to relevant app sections. Track interactions to optimize notification strategy and personalize content for better engagement. Displaying real-time stock prices requires continuous data streaming. Use WebSockets or libraries like Firebase or Pusher for real-time updates. Update only relevant UI components to keep the experience smooth. Throttle updates to avoid overwhelming the server and app. cache data for offline viewing, and handle errors gracefully by notifying users when data is outdated. Securing user data involves authentication, encrypted storage, and access control. Use Firebase Authentication or OAuth for secure logins, and validate tokens server-side. Store sensitive data encrypted with encrypted shared preferences or keystore. Encrypt data in transit with HTTPS TLS. Implement role-based access control on the server, minimize permissions, and regularly update libraries and run security tests. Robust caching strategy combines memory and disk caching. In-memory caching is fast but temporary, while disk caching persists data longer. Use HTTP caching with retrofit for API responses and define cache headers for control. Clear cache when outdated or low on storage. Use shared preferences or data store for lightweight data, and implement custom logic for specific cases like clearing cache on logout. Real-time updates are achieved with WebSockets, enabling two-way communication between server and client. Libraries like OKHTTP make WebSocket integration straightforward. Firebase Real-Time Database and Firestore push updates instantly. Server-sent events are another option, though less common. If WebSockets aren't feasible, periodic polling can be used as a fallback, though it's less efficient. For large lists, RecyclerView paired with the paging library loads data in chunks, reducing memory usage. Use backend APIs that support pagination and load data gradually as users scroll. The view holder pattern ensures efficient recycling of views, and diffutil improves performance during updates by detecting list differences. These techniques keep your app responsive and efficient. Work Manager is the preferred solution for reliable, periodic background tasks. It persists across app restarts and device reboots. Job Scheduler is another option for Android 5 and above. Set constraints to ensure tasks run only under certain conditions like Wi-Fi or charging to save battery and data. Schedule tasks at off-peak times and avoid high-frequency tasks to prevent battery drain. Manage user sessions with token-based authentication, storing access tokens securely in encrypted shared preferences. Track session expiration and auto-logout users when needed. Use background processes for silent token refresh, keeping users logged in seamlessly. For multiple devices, implement server-side session management to handle sessions across platforms, ensuring security and consistency. Integrate analytics SDKs like Google Analytics, Firebase Analytics, or Mixpanel to track user events. Define custom events for key actions to understand engagement and usage patterns. Ensure GDPR and CCPA compliance, letting users opt out of data collection. Store events locally if offline and batch send them when connectivity returns. This approach provides valuable insights while respecting user privacy. Apps with dynamic content like news feeds rely on backend APIs, REST-TFL or GraphQL to deliver updates. Use RecyclerView with the paging library for infinite scrolling. Implement pull to refresh for manual updates and load more items as users scroll. Cache data locally so users can view content offline, and use Work Manager for regular syncs. Push notifications alert users about new content, keeping them engaged. MVVM and MVI are foundational architecture patterns in Android development. MVVM separates the model view and view model, making code modular and testable. MVI focuses on unidirectional data flow, simplifying state management. Both patterns enhance scalability, maintainability, and ease of testing, making them ideal for modern Android apps. Repository pattern acts as a single source of truth for app data. It abstracts data sources, deciding whether to fetch from local storage or remote servers. This pattern simplifies data management, improves testability, and ensures consistency across the app. By centralizing data logic, developers can easily scale and maintain their apps. Work Manager is Android's recommended solution for scheduling background tasks. It guarantees task execution even if the app is closed or the device restarts. Work Manager supports constraints like network availability and battery status, making it ideal for syncing, backups, and periodic tasks. Its reliability and flexibility make it a cornerstone of modern Android development. Encrypted shared preferences provides secure storage for key-value data in Android apps. It encrypts data at rest, protecting sensitive information like tokens and user settings. By leveraging Android's security APIs, developers can ensure user data remains safe from unauthorized access, enhancing trust and compliance. Firebase Cloud Messaging (FCM) is a powerful tool for sending push notifications to Android devices. It supports topic-based messaging, allowing targeted notifications. FCM integrates easily with Android apps, providing reliable delivery and rich features like notification channels and deep linking. It's essential for user engagement and timely updates. Room is Android's official SQLite abstraction, simplifying database management. It offers compile-time checks, easy migration, and integration with live data and view model. Room is ideal for storing structured data locally, supporting offline functionality and efficient data access. Its reliability and ease of use make it a staple in Android development. Retrofit and OKHTTP are leading libraries for network communication in Android. Retrofit simplifies API calls with a declarative interface, while OKHTTP handles HTTP requests and caching. Together, they enable efficient, reliable networking, supporting features like gZIP compression and cache headers for optimized performance. Glide and Picasso are popular image loading libraries in Android. They handle image loading, caching, resizing, and transformation efficiently. Both libraries support memory and disk caching, placeholder images, and error handling, ensuring smooth user experiences even with image-heavy content. WebSockets enable real-time, two-way communication between server and client. They're ideal for features like chat, live updates, and stock prices. Android supports WebSocket integration with libraries like OK-HTTP, providing instant data delivery and efficient resource use. Firebase Real-Time Database offers instant data synchronization across devices. It's perfect for chat apps, collaborative tools, and real-time feeds. Firebase handles data updates efficiently, pushing changes to clients as they occur, ensuring users always see the latest information. The paging library helps load large data sets in chunks, reducing memory usage and improving performance. It integrates seamlessly with RecyclerView, supporting infinite scrolling and efficient data updates. Paging is essential for apps displaying long lists or feeds. Diffutil is a utility class for efficiently updating RecyclerView lists. It calculates the difference between old and new lists, minimizing UI updates and improving performance. Diffutil is especially useful for dynamic content and real-time feeds. Job Scheduler is a framework for scheduling background jobs in Android 5 and above. It allows tasks to run under specific conditions like network availability or charging. Job Scheduler is useful for periodic tasks, backups, and maintenance operations. Encrypted Room extends Room database with encryption, securing structured data at rest. It's ideal for storing sensitive information, ensuring compliance and user trust. By combining Room's features with encryption, developers can build secure, reliable apps. OAuth 2 is a secure token-based authentication protocol. It enables safe logins and access management, supporting third-party integrations and user privacy. Android apps use OAuth 2 for secure authentication, often with libraries like Firebase Authentication or Auth0. A CDN distributes content globally, reducing load times and improving user experience. For image-heavy apps, CDNs ensure fast access regardless of user location. Integrating a CDN with your app storage solution is essential for scalability and performance. Connectivity Manager monitors network availability in Android apps. It's crucial for offline-first strategies, ensuring data sync only occurs when online. By leveraging Connectivity Manager, developers can optimize sync logic and improve user experience. Role-Based Access Control (RBAC) limits data access based on user roles and permissions. It enhances security by ensuring users only access what they're authorized to. RBAC is implemented server-side, supporting compliance and protecting sensitive information. Data versioning tracks changes and ensures the latest information is available. It's essential for conflict resolution in offline-first apps, helping determine whether server or device data is newer. By maintaining version history, developers can avoid outdated data issues. Optimistic UI updates show changes immediately, syncing them in the background. This approach improves responsiveness and user satisfaction, especially in offline scenarios. By updating the UI first and syncing later, apps remain fast and interactive. Deep linking enables notifications and external links to take users directly to specific app sections. It enhances engagement and streamlines navigation, making it easier for users to access relevant content quickly. Ensuring analytics and event tracking comply with regulations like GDPR and CCPA is essential. Let users opt out of data collection and handle data responsibly. Compliance builds trust and protects user privacy, supporting long-term app success. We've now explored the top Android system design interview questions and answers, covering architecture, caching, notifications, security, real-time updates, and more. By mastering these concepts, you'll be well prepared for interviews and ready to build scalable, secure, and efficient Android apps. Continue learning and practicing these strategies to stay ahead in your Android development career. Thank you for watching and best of luck in your interviews and projects.